Welcome back to the channel. So I present to you my poor man's whiteboard. I've used these before. All they are is a 4x8 sheet of paneling from Lowe's, but they work pretty well as whiteboards. Figured that might be better than having the shadows with paper. So in this video, I wanted to give some suggestions of what I would keep around the house for electrical tools, but I think it's also really important that you know what they're capable of and how to use them properly so you can get the most use out of them. So if you can, just be patient with me for just a minute. I think what I'd like to start with is showing you kind of the basic nature of electricity, how it's generated and how it's used. And then I want to show how to use some of these electrical devices or some of these electrical tools, and then get into some of the other just miscellaneous tools that I would suggest. So I know water and electricity don't mix, but let's use a water analogy to describe electricity. Let's say you have a water plant, and over here, I'm just going to draw it two-dimensional, we have a water tower. So the water plant treats the water and pumps the water up to the water tower. So as the water gets pumped, the water plant pumps put pressure on the water and push it through so there's a flow of water up to the water tower. So let's put this in electrical terms. If we have our water plant, let's say if we have our water plant, let's say that's the same thing as a power plant or a generator. You might have it at your house for emergencies. Now you have your pipe, which goes over to the water tower. So your pipe, or more of your pipe diameter, in electrical terms, is going to be called resistance. You can only put so much water through that pipe. And in an electrical circuit, it's the same thing. You can only push so many electrons through the circuit. The flow of water going through the pipe, in electrical terms, can be called amperage. And the push that the pumps create, and actually, let's do this. Let's call this pumps instead. The pumps of the water plant. So this is going to be more like we'll just call it a generator. So the push that the water pump puts on the water, the pressure, it's going to be voltage. So if you remember from a few videos ago, I talked about how a circuit has to be a continuous loop. And I had a switch over here and a light. So let's put this information into a circuit. So we have our generator, but let's also just call this plug it into an outlet. So all the circuit is just a flow of electrons. It's a closed loop, which is just a flow of electrons. So the flow of electrons is our amperage. And depending on what size of outlet we plug into the wall or what size of generator we have is going to depend on how much push these electrons undergo around the circuit. And regarding resistance, even though the wire is a conductor, voltage can only push so many electrons around, meaning with the amount of voltage put in, you can only get so much push through that wire, so much of a current pushing through that wire. So for the 100th time, Current is nothing more than electrons flowing around a wire, but there are two types of current. There's direct current, and there's alternating current. And you've probably heard these called DC power, AC power. So direct current, if we have a circuit, direct current means electrons only flow in one direction. So let's just say the electrons, just pick a direction. It's only going to flow in one direction. Let's just say that they're flowing in this direction around the circuit. Alternating current is a lot different. So what goes on an alternating current or an alternating current circuit is electrons move back and forth. So they're actually oscillating back and forth. So how the electrons move one way, this electron might move a certain direction, a certain amount in this direction, and then it'll move back to this direction. So these electrons are constantly oscillating back and forth in the wire. So it's absolutely crucial that you know what type of power you're analyzing with your voltmeter. So alternating current is what you have in your house, and direct current is more like your batteries. I'm a horrible speller too. So if I spell something wrong, don't put it in the comments, just leave it alone. So this is like your batteries and things like that. And even, not to confuse you, but even with your cell phones and your sensitive electronic devices, they actually have an inverter that actually will take the AC current coming into your house and turn it into direct current. So back to the water tower analogy. This is ground level. So if this is the push coming down, just from what you know about water pressure, what would be the push, say, coming from the ground to say like 10 feet? It probably wouldn't be very much, right? So let's say that the height of the water, obviously creating a push down, this would be relatively low voltage. But what if we went to the full height of the water tower? So now all of a sudden we have, I don't know, let's call it 400 feet. This would be a really high voltage, right? Because you have all this pressure coming down. And so when you hear high voltage power lines and things like that, that's essentially what you have. Don't think about the height direction, but think about the amount of energy that's being stored in those lines to have 37,000 volts pushing through. I mean, 37,000 volts is a lot of push. If you consider you have, say, a 12 volt battery, let's just say the 12 volt battery is somewhere around the 10-foot mark. Well, if you have 400 feet up, this is more like your high voltage power lines. And voltage, regardless if it's in an AC circuit or a DC circuit, all it is just a push. Just think about it as the push as it's trying to push those electrons around the circuit, whether it's pushing them one way and then pushing them back the other way in an AC circuit, or pushing them one direction around the circuit in a DC. Voltage is basically voltage. But this will at least give you some sort of visual with how the voltage works with the push. And that's why I kind of wanted to do this water example, just to help you understand how the circuits work. So why would I care about the height of the water tower or the height of the water at a certain point? So let's say we take the water level to be at this point. So obviously we want to know what the height is. So say this height is 0 feet, and let's just say this is 300 feet. So to get the pressure, we're basing it off from two different points. So with voltage, let me see if I can draw an outlet here. So with an outlet, aren't we just doing the same thing with a voltmeter? If we have This leg is, say, our neutral. So what's it at? 0 volts. But then what's our hot at? In the wall, it's 120 volts. So aren't we just measuring the same thing here? We have a 0 feet where there's basically no pressure, and then we go up into the water tower, we have 300 feet where there's a lot of pressure coming down. When you measure voltage, it's the same thing. You have a spot where there's basically no pressure at all, and then here's your push through your circuit, your 120 volts. So what we want to measure whenever we're measuring voltage is basically one point against another point. So on a voltmeter, for voltage, you might see DCV, direct current voltage, and then you might see ACV, alternating current voltage. On one of my voltmeters, it actually has a little battery, and sometimes you'll see a squiggly line with a volt, or with a V with a squiggly line over it. That's your oscillating current, your AC current. You'll also see something like this on some voltmeters. This just shows that instead of it being a squiggly line, it's direct current. So you want to make sure that whatever system you're analyzing, you have the setting right on your voltmeter. So you've already seen me use the multimeter. I keep calling it a voltmeter. These are called multimeters. So you've already seen me use the multimeter with AC circuits and other videos where I'll put the hot on the black wire on the gold screw and then put the black terminal on the white wire on the silver screw or in the outlet to make sure I'm reading 120 volts, make sure the voltage is correct. But there are applications for DC voltage. So I have these Ryobi batteries. I know one of them is bad and one of them's good. So these are 18 volts DC, they're batteries. So let's put it on 20 volts DC and we'll see which one of them are bad. So right here I'm getting 15.71 DC. But you also notice something, notice how it's negative. So all that means is that I have the wrong probe on the wrong terminal. So let's switch them. Now I have the common probe on the negative side of the battery, and I have the red, the positive, on the positive side of the battery. So now I'm reading 15.66 volts, but it's positive. Now what about this battery? Same thing. See how I'm getting nothing here? This just shows that this is a bad battery. And you could do this same test with your batteries in your junk drawer or whatever. If you don't know if they're good or not, you can test them, see what the voltage is. So in the water analogy, we had a pipe and our amperage was the flow of water, right? So how would we measure amperage? If we measure voltage from 2 points, basically being the difference in pressure, how would we measure the flow through the pipe? So you'd have to have some sort of flow meter, because what you'd want to know is you want to know how much water is flowing past this point per unit of time. So say the water's being pushed through a certain amount of pressure, pushing the water through, and say this is 100 gallons per minute. So it's kind of the same thing when you're measuring amperage. You're going to have to, if we have our closed circuit, it's a horrible circuit, but if we have our closed circuit, you can't measure the flow of electrons only at one point. It has to be within the circuit somewhere. So you want to know how many electrons are passing a certain point. So the only reason I address this, as a homeowner, I do these videos for homeowners. I'm just going to say right now, you're never going to need to know that. I guess if we could figure out some way to do a video in the future if somebody gets curious, but just to I kind of wanted to relate all the electricity together, because I think once you understand it a little bit better and you start putting circuits and things together, hopefully it'll give you a better understanding of what you're doing. But as far as measuring the amperage, you're not really going to need to know to do that as a homeowner, and I certainly don't recommend anybody doing it as a homeowner. But long story short, if you wanted to measure the amperage in a circuit, you'd have a setting on here where you need to know which type of amperage you have. So let's just say we're doing DC amperage. So you'll turn it to your DC amperage setting. But then what you have to do is you have to actually break the circuit, and you have to hook the terminals up to each side of the circuit. Now the electrons are flowing through. I'll tell you what, let's do it like this instead, so you can actually see. Let's say we break the circuit down here. Now, if we have our setting to amperage on our voltmeter, and you hook it to one side, and you hook the probe to the other, now what you can do, or now what you're measuring, is the flow of electrons going through the circuit, through the positive terminal, through the multimeter, and back out through the circuit. So now you've made the multimeter part of the circuit, and it's going to measure amperage, or the flow of electrons. So if you were to go pick this up from the store, say this particular model, you could analyze the AC voltage and DC voltage from what you just learned. And this little 1.5 volt and 9 volt, that just pertains to batteries. So you can kind of decipher some of this stuff just on what you've learned today. What you want to learn next is the range. If you're going to analyze a 120 volt circuit, you obviously don't want to put it on 600 volts. Just go ahead and turn it to 200 volts. And then if you got direct current, and say you're going to analyze a car battery, where do you think you'd put it? You've got 600 volts DC, 200 volts DC, 2 volts DC. Where do you think you'd put it if you're going to measure a 12 volt system? Of course, you'd put it at 20 because it's just above what you want to measure. So you see down at the bottom where the probes actually hook into. So right above them, the common would basically be your neutral, and the other terminal would be, if you look at it, you can kind of see where it has the battery and amperage, voltage, and so you know that you need to plug the other terminal in there when you first buy it. This one is kind of the same thing. You just have to kind of look at what you're trying to analyze. I'm guessing you're not going to use any of the amperage DC. So obviously when you buy one of these, you'll want to plug it into the other two terminals. Just make sure that they're in their proper terminal. So the common is usually your black on these voltmeters, and then the red is your power. So the black would be your neutral, essentially, and the red would be your hot or your positive. If you're going to do-it-yourself electrical projects at home, you're definitely going to want a multimeter. And hopefully after seeing this video, you can kind of see that they're not too scary. There's just certain settings that you need to set the multimeter to, and you just got to know what type of circuit, whether it's DC, AC circuit, and kind of how to, what you want to analyze. The next tool I'd recommend you getting is a non-contact voltage tester. A lot of the professionals call these death sticks. I don't think that they're that dangerous if you know how to use them properly. So what you'll do is you'll turn them on, and wherever you come in contact with voltage, it'll light up and tell you that somewhere along there's voltage. So obviously if this lights up, there's voltage, so there's a live circuit in some capacity. How I usually use these is I go find something that is on, so I know that this outlet is live. So to test it, I won't just turn it on because maybe it's not working properly, or some of them, they don't actually have a light that turns on. You'll just turn it on and you don't know if it's actually working or not. If you're ever going to use one of these to go see if there's a live circuit or if there's any power in a box or anything that you're working in, go take it and test it against something that's actually, that you know is live. So if you're starting a brand new garage project or something like that, and you say have your sub panel in, go test it against your sub panel. Go test it against something that you know is live. The next tool I'd recommend is this plug-in tester. You see it just plugs into an outlet. And there's a bunch of different codes along here. I'm sorry, my camera's not picking them up. There's a bunch of different codes along here that when you plug this in, if there's something wrong, it'll tell you. Like the first one is open ground, next one is open neutral, and these different codes will actually tell you if it's right or wrong. And right down here at the bottom, it's correct if you get the open circle and then the 2 yellow circles. So let's go give it a try. So there's a red light, 2 green lights. So with the 2 green lights, according to the code, this is wired correctly. It doesn't hurt to have one of these. They're not that expensive, and a lot of these come in a set. And there's been times, especially when I was starting out, that I'd be sitting there wiring stuff up, maybe you're not quite paying attention like you should, and you go plug one of these in there and it'll be the hot and the neutral be reversed or something like that. I never had a problem with the other ones, but generally it's like the hot and neutral. Maybe accidentally put it on, switch the wires from the gold screw to the silver screw or something simple. But this will tell you if you've done it right or not, especially if you're starting out. It definitely helps. And I actually bought all 3 of these in a set, and that's probably the most economical way to do it. The next tool is an actual electrical screwdriver. And what I mean by that is it's insulated on the end, and you can see it has a bunch of different bits in it. And you'll want a bunch of different bits based on what you're doing. So say you're going to be wiring up outlets. You want a big Phillips bit to screw in the screws on the side of the outlet. But if you're taking off cover plates, you need a small flathead bit to screw in the screws. And there's some other, if you need a nut driver, some of these double as nut drivers. And so these are really handy. But what's most important is they're also insulated. Wire strippers. Invest in a good pair of wire strippers. I don't because I'm cheap. But if you're going to be doing a lot of work, definitely invest in some good wire strippers, because you don't want to be cutting the wires or stripping wires, especially if it's stranded wire. You want to make sure that they're stripping the wire properly, and not, especially with stranded wire, where you can actually cut off some of the wires and make the wire actually smaller. So you want to make sure you get a good set of these. Utility knife, you've seen me use this a bunch of times in my videos. You can cut Romex with these wire strippers, but they don't always work that well. So what I would recommend is getting a good set of cutters. I got these from Harbor Freight. These actually don't suck. These are what I use when I go out and do side jobs. I'd also recommend needle nose pliers. I use these a lot, and what I usually use these for, you saw me kind of curl the wire around the screws on an outlet with these, but a lot of times I'll use these instead. I guess I'm just kind of pressed for time and thinking about too many things when I'm doing videos, but I like using these and then going and using the needle nose to actually crimp the wire around the screw before I screw it down. So you definitely want to have a Sharpie or some sort of permanent marker. Whenever you're running lights, multiple lights, or you're running wires that are going to feed multiple circuits, you definitely want to have a Sharpie and label properly where the wires are going and where they're coming from. You definitely want to have a tape measure handy. Usually what I have when in my tool kit is I just have a smaller tape measure. I usually don't have a 25-foot tape measure. I usually don't need it. And the reason I keep a dedicated tape measure is I'm super good at losing tape measures, so I just keep one in my electrical kit. Of course, a hammer. Definitely want to have one of these around, at least available. You don't have to have one in the kit. I keep one in the kit that I have. If for no other reason, you just get frustrated and start hammering on stuff. You definitely want to keep some electrical tape around. Keep this in an electrical kit, and that's something I'd recommend with all of this. I'd keep all of this together. Maybe not necessarily the tape measure and the hammer, but all these other electrical tools, I'd definitely keep them all together, so whenever you need them, you have them. So I definitely keep electrical tape. And something else I would keep is most of the little pieces that you get out of, say you're putting in a ceiling fan or
You just have some pieces left over, or keep a couple wire nuts on hand, or one of the Romex connectors. In the little tool pouch that I have a ton of this stuff, and a lot of times I end up throwing it out, but I save a lot of this stuff so in case I need it, I have it available. And it might be a good idea to maybe just have a little jar or something to where you keep some of these extra pieces in. This will actually go to a ceiling fan bracket. This went to a ceiling fan shroud that I took out. This will screw into those plastic boxes to hold those little white lights or other fixtures in place. So any of these little pieces you can keep. I wouldn't recommend keeping a ton of them, but definitely keep some of this stuff on hand in case something happens, you end up losing a part. I've stripped these out before. That's why I like to keep some of them around when I take out the old ceiling fans. So this is what my tool pouch looks like. I just put all the tools in there, and I can just hook this to my belt and walk around like a goon and go do electrical stuff. I know this looks pretty cheap, but I've made a ton of money off from this little kit. And I know, you know, if you put something small like this together, you can certainly save yourself a lot of money getting work done yourself. But it's also nice that I have all the tools together, so whenever I need it, I just go grab it and go. So I hope this video has helped you understand circuits a little bit better. And you saw the recommendations that I have for the tools that I have. I actually do professional type jobs, residential type jobs, and those are all the tools that I basically need to get the job done. And I hope this video has helped you understand how to use them a little bit better. So when you go out and get a new voltmeter, at least you can put it on the right settings and use it for the proper application. So we hit 5,000 subscribers a little while ago, and we greatly appreciate everyone who has subscribed and who supports our channel. And we enjoy interacting with you guys online, and we hope we can put out a lot more videos. We kind of want to do this video first before we start doing more of the electrical work. We're almost done, but there's a few things that I kind of wanted everybody to know if you're going to watch the next video. So hopefully I can help tie some of these tools together when I start wiring the next video and testing some circuits. So we appreciate you watching. Hope to see you next time.